So we talked about the cerebellum. Now let's talk about the diencephalon. So this part right here is mostly showing the thalamus, and there are many parts to the diencephalon. I know it sounds very Greek and very complex what this diencephalon is. So the diencephalon is actually composed of not just the thalamus but many other structures as well. So this is joining the cerebrum, so again, that largest part of your brain, to the brain stem. So common misconception, especially if you're using the Martini book, it shows the diencephalon and the brain stem. So some people think that the diencephalon is part of the brain stem. It's actually not part of the brain stem. So the diencephalon includes things like the thalamus, the hypothalamus, the mammillary bodies, and the things called the epithalamus and subthalamus. So all of these have, except mammillary bodies, have thalamus in it. So if you see thalamus, think diencephalon. Now I want you to really concentrate on thalamus and hypothalamus. Epithalamus and subthalamus, don't worry too much about for this class, but just know that are part of the diencephalon. But thalamus and hypothalamus, yeah, I do definitely expect you to know what I'm going to cover. All right, so diencephalon. So this is going back to that neural tube. I know it's very complex and has all these new vocabulary that you've never seen before, but this is why. So here we have the diencephalon, and this is part of your neural tube, the vesicles, and then what we have here is that the thalamus, hypothalamus, and epithalamus and subthalamus are all derived from this. So this diencephalon eventually becomes all these structures. Now, here we have a thalamus right here. So notice that's kind of central to the brain, and the hypothalamus. Now, OpenStax includes the pituitary gland. To be more specific, it's actually the posterior, the back. The pituitary gland in humans has two main lobes, and the posterior part is part of the diencephalon. But that we'll cover. Don't worry too much about the pituitary gland. We will cover a lot, or actually, don't go too in depth, but we will cover that way more in depth in next semester. Okay, so then we have and just like a little preview of things to come, we're actually going to cover the cerebrum more in next lectures because, again, the cerebrum, biggest part of the brain, very complex, so I think it deserves its own lecture. But here we have the frontal lobe, and hey, where is your frontal? Or actually, frontal lobe, there are four main lobes to the brain. So you have the frontal lobe, the temporal lobe, the parietal lobe, and the occipital lobe. Hey, what does that sound like? That sounds like those cranial bones, right? So again, this is why I wanted you to know all the bones and all these areas, because they pay off further and further in the semester. Now here we have the thalamus, and notice that it's in the middle of all that. That's not coincidental, because what it does is it sends signals to all of these lobes. It also coordinates signals from the lobes, and not just the lobes, also the cerebellum and signals coming from the brainstem and spinal cord as well. So the thalamus is kind of like a major or grand central station of your brain. It's there coordinating all this traffic and all these signals. Now this image, do I want you to know which part is which? Now, for advanced classes, they might require this. What I'm showing this picture, why am I showing it? Is that I'm showing you that you have all this stimuli and signals going to the thalamus, and all this trade between these signals between the thalamus. So the main thing I want you to know, it coordinates input from all these sensory systems. So it's not. So, I mean, do I want you to memorize this laundry list? No, but you should know that this is why the thalamus is very important. It's getting all these signals, receiving all these signals, and coordinating all these signals. So the thalamus is like a central hub or relay station. That's why I say it's kind of like Grand Central Station, or I mean, if you're from, or maybe more Hawaii analogy, maybe like something like the Kalihi Transit Station or Kapolei Transit, or maybe Kalihi Transit Station, downtown transit station, because it's why it's coordinating all this traffic. It's also important for not just coordinating these signals and just a relay hub. It's also important for the overall consciousness, like how do you know where you are? How do you aware of yourself? And are you awake and not asleep? So the thalamus is also important in that. And things that, because it coordinates all these sensory signals, if you have lesions and damage to the thalamus, that can cause sensory processing disorders. So you can get those signals, but it might not be actually reaching the cerebrum, or it might not eat, or it might be misdirected instead of going to the right area. And there's a really cool condition called synesthesia. Now synesthesia can be caused by multiple things, but one interesting thing, this case right here in this journal. So after 9 months of suffering stroke, and they found out that stroke affected the thalamus, this patient noticed that whenever he read a word, and this is visual input, so then he would feel disgusted. So instead of his brain interpreting, okay, this word is blue, now I'm going to get disgusted. Instead of just thinking like, okay, this is the word, it's this color. And then interesting thing is like raspberries. So he's getting all these stimuli from his tongue. So it should go to the parts of his brain that interpret taste. But now it says it tasted like blue. So now it's going to the visual part. So all his signals are getting mixed up because of this damage to his thalamus. Now, does that mean you need brain damage to get synesthesia? There are people who actually have this synesthesia and they don't have brain damage, but for some reason, sometimes these signals either get redirected, like this patient, or they get mixed up. Sometimes when they read something, they see color, even if for the rest of us, that word is written in black. It's really cool, but I mean, and the thing is that they don't feel like they're disabled or like they are colorblind or they have something different. That's just that was really cool. There was a student who actually had synesthesia, and she says I think she saw colors when she heard music, but that's her world. She's known that from the start, so it's not like something that all of a sudden hit her and now she's like totally confused about everything. It's just how she experiences the world. It's really cool. I mean, that's why the brain's so cool. Okay, back to the diencephalon. So we talked about the thalamus. Now, what's below the thalamus? Hey, what's that prefix that means below? So below the thalamus, we have our hypothalamus. Now, the hypothalamus is very important, but you can really go down the rabbit hole. So I'm drawing a tight circle here with the hypothalamus. So very important in many things, including controlling homeostasis. So like regulating your body temperature. Are you too hot? Are you too cold? And also your food intake as well. So if damage to the hypothalamus, it can cause someone to be perpetually hungry or have no interest in food at all. It's very interesting. Fear and stress responses. So the thing is that hypothalamus is also important in not only just like detect or also coordinating how you react to scary or stressful situations. And it's very important in the endocrine system. And when you think the endocrine system, you think of the magic word is hormones. So the endocrine system involves these hormones, and the hypothalamus, it doesn't control all hormones, but it controls like pretty much the vast majority of hormones are regulated somehow by the hypothalamus. So many of the hormones in your body are regulated by this structure in your brain. And more to come in PHYL 142, because endocrine system is what I say for PHYL 142. I don't think we have enough time to really cover the endocrine system in PHYL 141. Okay, so then here we have the diencephalon. Now let's go below the or actually inferior to the diencephalon.